this video we're going to start our adventure with surds. So surds are quite a big topic from higher GCSE and upwards, so we definitely need to know how to play with them. There's a lot to them, so this video is going to be a brief introduction to what they are and a few little rules about them. So hopefully by the time you're watching this video I've created a nice big playlist all about surds, so be sure to check out the other videos. Okay, so let's get cracking. So first of all then, what are surds? Surds belong to a family of numbers called the irrational numbers. Now an irrational number is one such that it has an infinite number of decimal places. Now in particular, surds pop up when we try to square root a non-square number. So for example, we're probably all pretty happy that if we tried to square root 9, then we wouldn't really have much of a problem. We know the square root of 9 is 3. If we tried to square root 100, and we know the square root of 100 is 10. So those aren't surds because we can express those as nice, normal, rational numbers. What happens though if we try to square root 2, or we try to square root 15, or we try to square root 50? None of those numbers under the square root signs are square numbers, so they can't be square rooted nicely. So they are going to be irrational, and it's much more useful for us to keep them in square root form, because when they're in their square root form, they are the exact value of the surd. So root 2 is exactly equal to root 2. It has all the information of those infinite decimal places in there. Whereas if we start writing them out in decimal form, so if you put the square root of 2 into your calculator, it will give you, if we go to 2 decimal places, it will tell us that root 2, now a wavy equals sign like that means is approximately equal to. So if we go to 2 decimal places, root 2 on your calculator will be 1.41. Now the problem with that is we've lost an infinite amount of information after the second decimal place. So root 2, again, is exactly equal to root 2. If we start expressing it as a decimal number, then we're only approximating. It's the same as with pi as well. When we lop off the decimal digits of pi, we are losing accuracy. We are only approximating. If we keep pi as in terms of pi, then it's an exact value of pi. If we keep a surd in surd form, it's the exact value of that surd. If we start expressing it as a decimal number, we lose information. So surds are an exact form. Okie dokie, let's take a little peek at adding and subtracting surds then. So we can really closely link this to algebra. So if we try to add 2 different letters together, so say here x and y, we can't combine that into a single term because x and y are different beasts. They don't fit together. So the only way that we can describe x plus y is as x plus y. Yes, we could also call it y plus x. That's exactly the same thing. If, however, we try and add 2 x terms together, so say for example x plus x, we can happily do that. We're all happy that that would give us 2x. The same applies to surds. So if I try to add root 2 and root 3 together, that does not become root 5. We can't add or subtract the numbers underneath surd signs. So the only way that we can describe root 2 plus root 3 is as root 2 plus root 3. Again, yes, we could call it root 3 plus root 2, but the point is we can't combine it into a single term. Whereas if we had root 2 plus root 2 plus root 2, we can combine those into a single term because they are all in terms of root 2. So root 2 plus root 2 plus root 2 is pretty much exactly the same as doing x plus x plus x, and it would give us 3 root 2. let's say we wanted to do 5 root 5, add 3 root 5. Again, that's the same as doing 5x plus 3x. 5 root 5 add 3 root 5 is going to give us 8 root 5, like that. Now it's exactly the same for subtraction. So let's say we had 10 root 2 and we wanted to take away 3 root 2, then that would give us 7 root 2. And I've gone off the edge of the screen, I'm sorry. 7 root 2, like that. Okay, so addition and subtraction of surds works pretty much exactly the same as with algebra. You can only add or subtract common terms to and from each other. Okay, so let's take a peek at some other important rules with surds. Now this one is very useful. This comes into use when we're simplifying surds. Again, I'm not going to go into that here. Check out the video on it. So we can split up. If we have a multiple underneath a surd sign, we can split it up into the square root of one factor times the square root of another factor. So here, if AB is our multiple, 2 factors of AB would be A and B. So we can say that root AB is equal to root A root B. So for example, we could express root 6. Well, we know that 6 is 2 times 3, so we could express root 6 as root 2 times root 3. We could express root 10 as root 2 root 5, because 2 times 5 is 10. We could express root 45 as root 9 root 5. Now then, once we've done that, this is actually an example. This is actually an example of simplifying surds. We've got a square root of 9 there at the start, and we can happily square root 9 to get a nice normal rational number. So we can actually write root 45 as 3 root 5. Again, I'm going to do a separate video on that, don't worry too much about it here. But that is an example of simplifying surds. Okay, on to the next. So the square root of a whole fraction is equal to the square root of the top divided by the square root of the bottom. So for example, if we apply this to, say, let's say we've got the square root of 25 over 4, then we could say that this is equal to root 25 over root 4, and then root 25 is 5, root 4 is 2. And so square root of 25 over 4 is equal to 5 over 2, which I know doesn't contain a surd, just an example of how that rule works. And then the last one that we need to be aware of is if we have the square root of a number times the square root of the same number, then our answer is just going to be that number. So, for example, if we have root 2 times root 2, that will give us 2. If we have root 10, that's going to give us 10. So that's another really useful little trick. That one comes up quite a bit actually when you're simplifying surds again. So that's all we need to know for an introduction, I think, guys. So remember to check out the rest of the playlist, and as always, message me with any requests or help. Cheers, guys.